Today we're going to talk about hair color bias in keratinized matrices for drug testing. We're going to talk about how drugs and metabolites are incorporated into hair. We're going to discuss the limitations of hair testing. We're going to discuss the anatomy of nail and nail formation. We're going to discuss the advantages of nail testing, how drug and drug metabolites are incorporated into nail, and then we'll have a few examples of comparisons of hair and nail in the literature as they relate to hair color. Hair testing has been around for several decades. As you can see from this diagram, drug is incorporated into the hair, and then once you cut the hair, the drugs are trapped in the keratinized proteins and is available for us to extract out and analyze. Hair testing has a number of advantages. It's a relatively simple, rapid, non-invasive collection. You don't have to have any privacy issues or male or female staff for collections. It yields a long window of exposure, 90 days, sometimes even longer. And even though hair testing is generally more expensive than other specimen types, if you back it down to the number of dollars per day of information that you're getting, it really comes out to a very economical dollar per day ratio. Hair is easy to ship and store. It's not a biological hazard, so that reduces a lot of the requirements for shipping and for storage. And at the laboratory, we store it at room temperature, so those costs are not passed along to the user. Hair is relatively simple to analyze. Depending on your background, hair is much easier to deal with than, say, tissues from post-mortem type fields, and those can be extremely difficult to extract. Hair is dry, you grind it up, you extract it, and off you go. And again, there's no known infection risk. So a number of variables here are advantageous for conducting hair testing. How do drugs get into hair? First and foremost, we have environmental exposure. If you're in an environment where drug is being smoked, handled, distributed, cut, cooked, etc., that drug will contaminate the environment, which includes you. And so we're talking about a physical transference of the drug itself to your hair. Now your hair is porous, and the drug gets on your hair. It works into the nooks, crannies, and pores, binds to the proteins and pigments, and is available to be harvested and analyzed immediately. Route number 2 is the sweat and the oil from the scalp. As these fluids bathe the hair shaft, they contain drug and drug metabolite. As they bathe the hair shaft, they deposit the drug and drug metabolite onto the hair. Once again, it works its way into the nooks, crannies, and pores, binds to the proteins and pigments, and is available to be harvested and analyzed. We begin seeing that drug show up a few hours following a dose. Route number 3, and this is what most people think about with a hair test. The blood traveling through the root deposits drug and drug metabolite and incorporates itself into the forming hair. And once it emerges past the scalp line, which takes about 2 weeks, it is available to be harvested and analyzed at that point. Now what we have at the end of the day are 3 extremely different modes of incorporation superimposed on top of each other. So it's a very complex picture. So we're not able to backtrack and determine time, dosage, and frequency. There's just too many variables. Once it's incorporated, it begins to slowly leach out due to normal daily hygiene and exposure to the elements. So for most drugs, there is a defined timeline that we'll be able to find a detectable amount of drug. And just like any other specimen type that we encounter in the laboratory, hair has limitations. And we need to appreciate those limitations when we're trying to interpret the results for our clients. First and foremost, bleaching, perming, dyeing, chemical straightening, or just cosmetic treatment. All of these processes contain varying amounts of either reducing or oxidizing agents. And depending on the drug, the hair color, the type of treatment, extent of the treatment, it can affect the drug concentrations in the hair. A good example was described back in 2001 by Tanaka. He described that methane plus hydrogen peroxide resulted in a host of hydroxy products. We are not looking for these hydroxy products, and neither do our immunoassays look for these hydroxy products. And so the likelihood of achieving a negative strain of confirmation is increased. We're familiar with hydrogen peroxide as far as bleaching goes, but what most people don't consider is that many of the hair dye preparations will contain varying amounts of hydrogen peroxide. So we have to consider all cosmetic treatments. Another one is the chemical relaxer. When I was at the Society of Hair Testing a couple of years ago in Toronto, I had the opportunity to see a presentation by Dr. Pritchett, her findings at the Society of Hair Testing meeting, and then later published it in the Journal of Analytical Toxicology. And she had some very interesting findings on the effects of using chemical relaxer. First, I did not realize that chemical relaxers or hair straightening or processing hair, I didn't understand that they came in two types. There's one that contains lye and one that does not contain lye. And so she presented information using the cocaine, PCP, and marijuana with fortified samples, and she showed the results of treated hair versus non-treated hair. And as you can see, the untreated hair had significant levels of cocaine, PCP, and marijuana. The samples that were treated with the lye-based hair relaxer, the numbers are very much lower as a result of that treatment. And with the non-lye, it also had a very reducing effect on the concentration. So any hair that's cosmetically treated, we have to be aware that these particular samples, most of the compounds were reduced significantly. These were above the cutoff, but we have to be aware that if someone was just above the cutoff, these treatments will knock the concentration down below the cutoff. Now, the previous table showed fortified samples. Now, these are authentic specimens. These are hair specimens from users of cocaine, and we looked at she looked at the untreated results, and we see significant amounts of cocaine and cocaine metabolite. And then we got a significant reduction of the cocaine and metabolites with the lye and a significant reduction with the non-lye. And so we got even more of an effect with authentic hair specimens. So at the end of the day, there is a catch-22 with these cosmetic treatments. Bleaching, perming, dyeing, and other cosmetic treatments will cause drug to degrade in the hair if it's already in the hair. So the catch-22 is that these processes damage the hair. They make the hair more porous. They open the pores up wider. And so from that point forward, you can actually load more drug into the hair. And then coincidentally, once that happens with the larger pores, more drug can be washed out through regular hygiene. So it's a very complex picture once you involve cosmetic treatment into the equation. So hair color is one of the biggest variables in hair testing. And we're going to go over some data here from the literature, and some of this is quite old. This study here was from 1996. And what they did was they give codeine to white, brown, and black rats. And they gave them 40 milligrams per kilogram on a daily basis for 5 days. And then they sampled the hair from each of these rats and tested them for codeine. The white rats had 980 picograms. The brown rats had 5,900. And the black rat had 111,000 picograms per milligram of codeine in their hair. The reason for this is that one of the variables of the hair color that influences the concentration is the amount of pigment, or melanin. And the more melanin in the hair, the more drug can bind and the tighter it binds. But what was completely amazing to me is I would not have expected such a huge difference between the brown rat and the black rat. I would have assumed, if I was guessing the results, there would be a more even distribution of these concentrations. But there is a large disparity between the brown hair and the black hair as far as codeine goes. Now here's a second study by Slauson back in 1996, and this is a unique experiment in that instead of using different animals, we used animals that had both white and black hair on the same animal. That way, each animal is taking in 12 milligrams per kilogram daily, and so that normalizes perhaps any metabolism differences or feeding differences or dosing differences or what have you. So this normalized for a lot of variation here. So it's the same animal that did this for 5 days. They collected hair from the non-pigmented sections of the animal and the dark pigmented sections of the animal. And again, we got an incredible distribution of results. So when you call into the lab and you're asking me or one of my colleagues here, based on this number, is this person taking the prescription as described? Well, you know, one of the 500 versus 14,000, that is such a huge difference. So just knowing that hair color makes such a big difference, and in our demographic here in the U.S., we have every possible type of hair type and hair color. It's practically impossible to come up with some sort of paradigm to say that under this situation, this kind of number represents a certain type of usage. So you've heard me say this a million times if you guys are calling in and talking to me. Anytime you're testing a reservoir matrix or matrix where things tend to accumulate, we are not able to backtrack and determine time, dosage, and frequency. There's too many variables, and here is one of the biggest variables that you will encounter. So talking about rat hair is one thing, but we obviously test humans, and do these observations carry forward into human hair? And here is a good study that was published back in 2004, and they were looking at individuals that were given 10 milligrams daily of zolpidem. You know, this is Ambien. And so they did that for 3 days, and these individuals had salt and pepper hair or grizzled hair. And so you had dark hair and you had gray hair. So they collected the hair and they separated out the specimens by color and analyzed them. And look, we saw the same observation here. The non-pigmented hair had 0.4 picograms per milligram of zolpidem, and the black hair had 39. So that's an 80-fold difference in concentration based on the color. And this is from the same individual taking the same doses for the same period of time. Huge difference in the concentration that we find. Here's another study that was presented here in Des Plaines back in 2004 when we hosted the Society of Hair Testing by Dr. Rawlings. Here we looked at several donors that were characterized by their hair color: black, brown, dishwater blonde, and red. And each subject was given 30 milligrams by mouth 3 times daily for 5 days, and they collected that hair out over 7 weeks following the dosage. And then they analyzed the first 1.5 inches each time they collected. And what they found was that according to hair color, as expected, we had a wide range of concentrations. So black hair at 1,000 picograms, brown hair at 250, dishwater blonde at 119, and red hair at 66. So these are individuals that were all given the same dose over the same period of time. The collections were made at the same time, and look at the wide range of concentrations that we see there. So with these alkaline compounds, which includes methamphetamine, cocaine, the opiates, which is heroin, hydrocodone, codeine, morphine, hydromorphone, oxycodone, and PCP, we have to be aware that hair color is a large variable when it comes to the reported concentration. And they further analyzed each specimen for the concentration of melanin, which is the pigment. And if you'll notice, the concentration on the left is the concentration of codeine found, and the x-axis along the bottom is the total melanin concentration. And as the concentration of melanin goes up, the concentration of codeine goes up, and it follows that best fit line rather well, which is further characterized by the R-squared value of 0.73, which is a very strong size effect for the concentration of melanin versus the concentration of codeine. That's a very strong correlation or association. In layman's terms, you can think of this that 73% of the codeine concentration is explained by the concentration of the pigment there. So that's a very strong variable. Other limitations, guys are collecting hair. You know, a lot of people come in and there's very limited hair. You have gentlemen with hardly any hair at all, and you have women with significant hairstyles that are not wanting to have them messed up. Maybe they're expensive hairstyles, and so you know, what can we do about that? Well, an alternative to this is using fingernail. Now, one of the nice things about fingernail is that it does not have pigment. And so with the absence of the pigment, we have just removed one of the largest variables of hair testing. But first, let's look at the anatomy of the nail. The nail forms in a place called the germinal matrix. There's a lot of blood flow there, and drug is incorporated from the blood at that point. You have the skin surrounding the cuticle, the nail, and so the sweat and the oil from that. You also have environmental exposure. So all three mechanisms that we're familiar with hair is also present with the fingernail. One additional variable is that as the nail travels along the nail bed, there's a lot of capillary blood flow under that nail. You can see that if you pinch down on your nail, it'll turn white and snap back to pink once you release the pressure. A lot of blood flow under there. And as that nail grows out to the distal edge, not only is that nail growing in length, but it's growing in thickness. And so nails are growing in two different directions, length and thickness. And you can review a lot of information in a review paper in Clinical Pharmacokinetics from an article back in 2000. Fingernails grow in length approximately 0.1 millimeters per day. Toenails grow approximately 0.03 millimeters per day, so somewhat slower. But they are also forming ventral layers by the nail bed. What does that mean? That means it's laying on material from the bottom side as that nail is growing out. That thickening rate has been determined to be 0.027 millimeters of thickness per millimeter of new length. So at the time that you cut a clipping at the distal edge, 20% of that total nail mass came from the underside as the nail is thickening as it grows out. Now, I was testifying in a case a year or so ago, and this came up, and I had to produce this as evidence of this fact. They were claiming that a nail clipping represented the couple of weeks period of time that the nail spent in the germinal matrix as it was being formed, and then the 6 months later when you clip, you have a 2-week period of time from 6 weeks ago. And so I had to present this evidence to overcome that mythology. And so we've all heard of the antifungal therapy drug called Lamisil. You see the little commercials on TV at night during ball games. And if you look at the structure here, you guys are probably not familiar with the structures that we look at, but you know, this is just another drug. There's rings, there's carbons, there's double bonds, there's triple bonds, and it's just another drug compound. And this oral medication is an pill, and once it gets into your blood, it penetrates into the keratinized tissue, and the concentration of this drug in your nail has to be above a certain concentration before it starts killing the fungus in question. And so this is what they reported, and this was a long time ago. This was back in 1990. So this has clearly been in the literature for a long time. No excuse for an expert not to have seen this data. And so as you can see, they gave this drug to the individuals for 28 days in a row. And on day 7, they began collecting nails, plasma, and stratum corneum. Stratum corneum is a layer of the skin. And as you can see, on day 7, they started seeing this drug show up in the fingernails. So how can that be? That's because as the drug erupts off the end of the nail bed or the quick, it's picking up drug there, and when we clip it, we're seeing that drug that was laid down over the past 7 days. And so this is the evidence, and this is what was presented, and so this is quite clear that drug is laid down by all 4 mechanisms in a nail test. Now, this is the fun part. Let's compare nail to hair. One of the early studies looked at 8 healthy African American males. It was a 10-week inpatient study with a 3-week washout, and they administered 2 drugs over a 6-day period with them alternating each day. And so we had 75 milligrams per 70 kilograms times 3 days, and then on the alternative day, 60 milligrams per 70 kilograms of codeine. And then they started collecting hair and nails. Here's a lot of numbers here, so let's kind of work our way through this. The left-hand column are your subjects, so subject A through subject N. And the second column is the maximum concentration of cocaine that we found in the hair of these African American males. The third column is the maximum concentration of cocaine that we found in their fingernails. The column on the far right is the ratio of the nail concentration to the hair concentration. Now, if you look at these at face value, you would say, oh my God, look how much lower the concentration of nail is compared to hair. There's no way that we can use the same cutoffs for hair testing. The piece that is not really discussed in the paper is the fact that these subjects were all African Americans. And African American hair is an ideal specimen type for detecting alkaline compounds in their hair. The hair is dark, it's coarser, it's curlier, which means it's got a little more porous action going. And so it's an ideal specimen type for the detection of cocaine. Nail has no pigment, so the hair color and the thickness and all of that is not an equation. It's not in the equation. When we move on to codeine, same thing, but even more. 5,900 down to 1,800 for the hair, and the nail concentrations range from 120 to 310. All of these are less than 10% of nail concentration in the hair. So one at first glance would say, hey, we need to perhaps consider different cutoffs for nail instead of hair. And here's a convenient table that I made to show the averages from the previous 2 slides. So the hair concentration mean was 6,100, the nail for cocaine. The nail mean was 850 or 14%. And for codeine, we had 3,200 picograms in the hair and 180 in the nail, which is 6%. Again, at first glance, one would perhaps assume we need a different cutoff for fingernail. But you remember the previous study that we talked about before we got into this study, where we looked at codeine concentrations versus hair color. And to refresh your memory, here was the concentrations that we found for each hair color. And these were not identical doses of codeine, but they were very similar. When we look at the nail concentrations from the most recent study I showed you, 180. Now, what jumps out to me is that by using fingernail, we have now normalized all of your hair tests to somewhere between a disorder blonde and a brown. And to me, this is important because, in my opinion, this makes this a more fair of a test. This way, people with really dark hair aren't being called positive for doing the same amount that a redhead would be called negative for. And so it normalizes for the absence of the pigment. Here's some other studies by Henderson and another paper in JPET back in 2005, where we had different studies using similar doses of cocaine, and we had black mixed race with 1,100 picograms of hair, brown hair at 390, and then another study. This was less of a dose, but over 3 days for African Americans, 2,997, and their nail results were 850. And so that kind of gives you sort of an idea of where you can expect the nail results to fall in relative to the hair and the hair color. Now, that's a big variable when it comes to testing for alkaline compounds. Again, the amphetamines, which includes methamphetamine, the opiates, the PCP, and a lot of the other compounds that we look for in our 17 panel. This phenomenon, or this observation, does not apply to acidic drugs. The most prevalent acidic drug that we look for is marijuana. Carboxy-THC is slightly acidic, and so the interaction between an acidic drug and the melanin is non-existent, and that's been demonstrated in many studies. So for marijuana, hair color is not a variable. And so we were able to look at a comparison of hair and nail from remnants of a larger study. We had 22 matched hair nail specimens. These are all from college students at a university in the Midwest. And what we found was quite fascinating in that in these matched pairs, we had 5 times a higher concentration of carboxy-THC in nail than in hair. And we've all struggled with the fact that hair testing can be a challenge when it comes to marijuana sensitivity. And so because of the additional thickness of the fingernail, it's preserving more of the carboxy-THC, and the effect of hair color is equal on both sides. There is no color in the nail. The thickness really takes charge, and we found 4,662 femtograms per milligram, or 4.6 picograms, and for the hair we found 0.8 picograms, or 844 femtograms. And so this was quite eye-opening, and a significant advantage of testing nail. We'll definitely be able to pick up more marijuana users using fingernail. Another slightly acidic compound is ethylglucuronide. And there's a large NIAAA, that's National Institute of Alcohol Abuse and Alcoholism. Large study, 529 matched pairs, again, college students from Midwest. And we looked at ETG in their hair and fingernail. And again, we saw 2.5 times higher the concentration of ETG in the nail than in the hair. And one thing that we realized from the hair ETG, because we had more samples, is that the female concentrations were much lower than the male concentrations, regardless of how much they self-reported that they drank. And we made the assumption, and again, more studies have to be done, that the cosmetic treatment, the higher probability of cosmetic treatment of the females in that study resulted in a skewing of the results for female ETG. Of course, we don't bleach, perm, dye, or fingernails, so that was no effect. We did not see a gender difference with the fingernail. Again, the thickness of the fingernail is 4 times thicker than a hair. Once it's incorporated, it's protected for a longer period of time. So this is quite exciting. For 2 compounds that are very difficult to detect in hair, fingernails seem to offer an advantage. Nail testing has been around for a long time. There's not many people out there pushing it as a viable alternative specimen, but rest assured, there's literature going back to the 70s on nail testing. Obviously, there's not as much literature, but it's definitely out there. Nail testing offers a slightly longer window of detection. The time that it takes for a nail to migrate from the germinal matrix to the distal edge is 4 to 6 months, depending on the health of the individual. And so when you make a clipping, you're getting a representation of that entire trip down the nail bed. So longer detection window for the drugs of abuse. It's still 3 months for ETG. difficult to adulterate. We have not encountered any adulterant that will actively destroy drug in fingernail, and I'm sure as soon as I say that, one will come up this afternoon in the lab. But at this time, the only problem that we have encountered are the gels and polishes, etc. They don't interfere with the test, but they add weight to the specimen, and we analyze by weight. So if we're weighing out gel instead of fingernail, then that's going to reduce your value accordingly. So that's why we ask for all the cosmetic treatment to the nail to be removed. And that's so that when we weigh it at the lab, we're only weighing the nail material and not some other stuff. It's not invasive. You don't have to worry about gender at collection. It's a direct observed collection. And again, the color bias is a huge variable that's been removed. So we thank you for your patience today. And if we have any questions, I'll be happy to do my best to answer them.
Here at USDTL, we are routinely asked, how do we ensure the accuracy of the results that we report? USDTL uses a defense in depth strategy borrowed from the military. Defense in depth takes an approach to risk that passes the specimen and results through multiple layers of test and review. It begins at the point of collection. USDTL provides 2 identical pre-printed barcode strips on the requisition form. One strip is peeled off and applied to the corresponding specimen container. This barcode creates the primary forensic identification for the specimen. At the laboratory, accessioning personnel scan the barcodes of the specimen and requisition form. The laboratory information management system forces a match prior to the receipt into the laboratory. A specimen whose barcode label does not match its corresponding requisition form barcode is rejected by the computer system. USDTL uses multiple identification for each specimen, such as the requisition form number, donor name and donor ID, and the laboratory accession number assigned at the time of receipt. Once accessioned into the LIMS, each specimen container is verified against a work list pulled from the system. Similarly, all requisition forms are reviewed against work lists generated from the LIMS. These review steps are conducted after all specimens have been received for the day. Each specimen forwarded to the initial testing section is identified by barcode label. The initial testing instruments read these barcodes, perform the tests, and automatically download the results to the LIMS. The instrument operator generates batch review reports to assist with the data review process, which includes review of the chain of custody, calibration, positive controls, negative controls, and patient results. Once accepted, a final reviewer reviews the data a second time. After acceptance of the initial testing data, the initial negative certification reviewer generates the final toxicology reports for all of the negative specimens. This individual verifies each field on the report. Lastly, a final negative certifying scientist executes the final review of the negative specimens and releases those reports to the client via fax or email. When the client receives the final toxicology reports, it is very important to verify that all of the identification numbers and names match with the numbers and names from your copy of the multi-part requisition form. If you observe any discrepancy, please do not hesitate to notify the laboratory to investigate. USDTL keeps all positive specimens for 1 year for the purposes of retesting. A retest incurs a confirm-only fee prepaid by the donor, and that is waived if the original result is overturned. Prepayment of a retest fee generally discourages insincere disputers. Laboratory personnel are human and mistakes can happen. Defense in depth and multiple layers of quality assurance are the best practice to ensure that results are accurate. If you have any questions, please feel free to call 1-800-235-5300. 2367. At USDTL, our clients are our priority.